Good day. What I would like for you guys today is to focus on what you remember when it came to relations. Okay? Relations was discussed in 1.6. And at that time, we talked about your input and output table. Of course, that's your X and your Y. And how we graph our inputs and outputs on a coordinate grid. In addition to mapping those ordered pairs. All right. In review, we'll go over these questions that we had went over last week on Friday. And we talked about, okay, so here the example says express the relation, which is your ordered pair 1, 1, 0, 2, 3, negative 2 as a table, a graph, and mapping. Well, here is your table. Here is your graph. And of course, here's your mapping. Now, you should remember that the first number in order pair is your x-axis, where it's graphed, and your y-axis. Okay, these are what we would like to call your directions. So, you are to label all your x in one column and your y in the other column. So you see here you have these two given numbers, and they are put on the table as such. And then you follow the same with the other ordered pairs that are given. Once you do that, you should be able to graph them. So when you go to 1, 1, you always start at your origin. You go 1, 1, and this is where the ordered pair, the point is for that. Then you go to 0, 2. Okay, origin 0 means you do not go right or left, and you're going to go up 2 from there. So this is your 0, 2. Then you have your 3, negative 2. All right, so I'm going to go to 3, 1, 2, 3, negative 2, down 2. And this is your 3, negative 2. So here's your table, your graph, and now mapping. So mapping is basically taking all your x and putting it in one box, and your y's and putting them in the other box, and drawing an arrow from one to the other. Now, we'll get into it a little bit more later, but when you have a number that repeats, you only have to write it once. Okay, so let's go down to an example before we move on to the function exercise. I want to make sure you understand this clearly. Given again your ordered pair, we're going to graph. Now in this exercise they graphed it for you. So negative 2, 1, negative 2, 1 is right there. Then 3, 3, 3, 3 is right here. And then 4, so we're going to take these, we have 4, 3 here, and apply them to the table. So I'm going to take my negative 2, negative 1, my 3, 3, and my 4, 3. Okay? And I'm going to apply that to the mapping now. So I'm going to put all of my x in one box and all of my y in the other. Now if you notice, we have two of the same number, so we just write that once. Then how does that look when we draw the arrows? So on our given ordered pair, these two went together. Then we have a 3 and a 3. So that 3 went with this 3, and that 4 went with this 3. So it looks as such. And then the last part is giving the domain and range. Remember, your domain is your x, your range is your y. So if we were to list these in a set, we normally want to go from least to greatest. So looking at our x values, our lowest number would be -2, our next highest would be 3, and our highest would be 4. So this is our domain. Then this next part is our range. You do the same, listing them from least to greatest and only listing the number ones. So it would be -1, 3. Okay? There is one problem that I would like you guys to complete, and that's on Google Classroom. So I want you to go there, and it's going to ask you to do the same thing that you see here that we've done on that problem. Have it ready to review and ask any questions when you come to class tomorrow. On to our functions. Now, what do we know about functions? Well, we also discussed briefly that to make a function, you cannot repeat an output. So, functions have for every input, which is your x value, there is exactly one output. So what does that mean? That means that when you look at these arrows here, to identify, looking at the mapping or looking at your table, your x value will not repeat a number. You will not see it in the mapping either, repeat. So let me go ahead into demonstrating that on these sample problems. Okay, so here, probably like Miss Williams would, I don't understand what you're saying about a function. Well, here we go. When you briefly look at this, do any of these x values have more than one arrow coming from it? And the answer would be no. So when I say that for every input there is exactly one output, that's what that means. Your input is -3 and your output is 0. So there's 1 and 1. Your input is -2 and your output is 3. Okay? Your input is 1, it came out -2, and your output is 1, or your input is 5 and it came out your output at 3. Now I'm noticing that here they listed the mapping from least to greatest, which isn't necessary on this side, which isn't necessary. That just, I don't know if it was coincidence in the numbers, but that isn't necessary until you list them in your domain and range. Okay, so you have this as a function. So this would be a yes. Okay, so that yes, it says determine whether each relation is a function. So that would be a yes. Now, do any of these values repeat? Yes, we have one here and one here. So because of that, it is not a function. Because does it apply to, for every input, there's exactly one output? No, because we have 1 here as an input and it comes out a 5, the output, and you have 1 here and it comes out a -2. So that is not a function. And now we have what we had discussed before, the VLT. And VLT stands for vertical line test. That means, does my line, my vertical line, cross more than one point? Well, it hits one there, it hits one there, 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 and there. So I only hit 1 point for every line that I went down. So that, yes, this is a function. Why? It passes the VLT test, or the VLT, okay, the vertical line test. All right, another way of seeing if it's a function, is looking at the given ordered pair and identifying whether any of the x values repeat. Do any of these repeat? And the answer would be no. So if they don't repeat, it's a function. Why? Because for every input, there's exactly one output. Let's look at number 5. Do any of these repeat? Yes. I have a 2 here and I have a 2 here. So no, this is not a function. Okay? Now when you look at x equals -2, if you were looking at on a grid at -2, for example, let's use this one. At -2, your line would be going straight up and down. And there are multiple points on that line. So no, this would not be a function. Y equals 2. Y equals 2 would be up here. Now if we had a line going like this and we did the vertical line test, we would only be hitting that line on one point. So yes, this is a function. Okay? And we're going to stop right there because our focus today is to be able to set up a relation and identify what a function is on this basis. This portion down here will be in your next video, next practice. It is going to be finding the value of each function by substitution. Okay? The last set of notes I want to go over are these practice problems right here. So again, determine whether each relation is a function. From what you can see, do any of these repeat? They do not repeat, so yes, it's a function. What about this mapping? Do any of these repeat or have more than one arrow coming from it? No, so it is a function. Now, look at this one. They may not have the numbers repeating, but it has 2 arrows coming from one input. Remember, it has to have, for every input, there's exactly one output. Well, this has 2, so no, this is not a function. Looking at the table, do any of these repeat? No, so it is a function. Do any of these repeat? Yes, so it is not a function. Do any of these repeat? Yes, it is not a function. Okay? Looking at your x values, do any of these repeat? No, so it is a function. Do any of these x values repeat? Yes. Number 6, so it is not a function. Okay? If you were to graph this using slope-intercept form, you would know that this is a function because it is not quadratic. We haven't gone over that, but if you were to graph this, and we'll talk more about this one in class, okay, but this is a function. And y equals 11, it is a function as well. The last 3 I want to go over with you is saying if it's a function. Now remember, the VLT. VLT stands for vertical line test. Does it pass it? Okay, so if I were to put vertical lines going all the way down this positive line here, does it pass the VLT? Yes, it does. So it is a function. Let's take a look here. If I put a line going through each of these points, so when I put a vertical line here, it only gets touched once. When I put a vertical line here, it gets touched once. If I put a vertical line here, once. If I put a vertical line here, oh, we have it gets touched twice. So it is not a function. Okay? And then you have this graph of being a parabola, and if I put the vertical line test, the line touches here and here. If I put one here, it touches here and here. And if I continue that, it gets touched more than once vertically. So no, this is not a function. Okay? Also, in addition to 1-6 practice, you're going to have an example on Google Classroom of a mapping, a table, a set, and a graph, and you have to identify if it is a function and indicate why it is or isn't. And I'm looking for it passes the VLT, or for every input there's exactly one output. So those are the two options I want you to use in explaining why what you indicated is or is not a function. Okay, so I will see you in class bright and early tomorrow. If there are any questions, just email me and I will try to get back to you as soon as possible.